Welcome back to Ox Tools. I'm Tom. So what we got going tonight is the second part of turning short machine tapers. So we're going to look at three methods for setting an accurate angle on the compound rest in the lathe. So we're going to go over to the lathe and I'll show you these three methods. There's a lot of material here, so I'm going to have to break it up into a couple of videos here, and it'll probably be better that way, so that way we're not so long on the videos. Anyway, so let's get an apron on, we'll go over to the lathe, and we'll look at how to get that compound set up really accurately for turning a precision short machine taper, okay?
Okay, so we're over on the lathe here, and we've got our first sample, or the first method here. We'll look at setting the compound angle with a sample piece. Now, so I want to show the three methods because, you know, it depends what you have available to you, right? So this is a commercial Jacobs 33 taper arbor to a straight shank here, okay? So this is our, and we're just going to show how to use this to set the compound. So I'm just going to snug that up in there. Now this isn't indicated yet, okay? It's running out a little bit, okay? But for purposes of the discussion, it doesn't really matter. So what you would do is you would indicate that very carefully so that it was running as true as possible, okay? If this is running out at all, then it really just kind of messes with the whole measuring scheme, okay? So the first step is to kind of do a rough setting of the compound, okay? And just as a reminder, the angle that we're setting here, okay, that's the half angle, okay? So that's 1/2 of this included angle of that taper, okay? And so that's our target number, okay? Now, I can tell you that that's a pretty small piece of an angle, okay? But let's go ahead and get the compound jacked around, okay? And get into kind of rough position. So I'm just cracking it loose here. Now, a smart guy would have broken this loose first. Actually, I probably still can't. Yeah. I'm learning something finally here, because you're gonna have to reposition this a little bit too. So we're just gonna leave that loose. All right, let's crack that and crack that. Okay, so we're free bird here. Now, I'm not gonna zoom in on the scale here, okay? You know, it's an angular scale. You guys can read an angular scale, all right? So there's 90 degrees, okay? So this is perpendicular to the cross slide now, okay? So what we want to do is we want to bump it over, and usually what I do is I just take up the slack in the screws, but I don't tighten them. That way that, you know, if these go into T-slots down here, right? So if they're too loose, they can be at an angle, and when you tighten them up, things want to move, right? So what I do is I'll bring them up and let them do their little movement. Then I'll bring them just so there's no play in there. Loosen that one a bit. Okay. All right, what's going on with that one? See, that's the exact reason right there, is it feels funny now. Okay, that's better. Okay. Same thing over here. So all that monkey business is taken out. Then I bump it, and I'm going to use my A-bomb knocker here just to tap on this. Now here's an important here's an important point. What we want to do is we want to work from this direction to this direction, okay? Not from this direction to this direction. And the reason is we're trying to hit a diameter down here, right? So if you start here and you're too steep, you cut too much off of that, or you can. So it's better just to work that angle in this way. So we want to start on this side and bring it to the angle, okay, as opposed to starting on this side and bringing it to the angle, okay? I hope that makes sense. So let's so what we want to do is just kind of come up a little bit shy of that, okay? And then what we'll do is we'll kind of snug it just a teeny bit more, probably so we can still move it, okay? But we're really kind of bringing it up close now, okay? And then now what we're going to do is we're going to get an indicator set up. Now there's some monkey business with the indicator that you'll see here in a minute, and there's a problem with indicating on a tapered surface like that. So, and I'll demonstrate that problem. Okay. Okay, so here we're kind of set up with a test indicator, and this is connected to the compound here. And so, normally, it's an easy thing to think about, right? You just run it up, we touch off, and then we use the compound to track along this. Okay, now there's a big problem with that method, and I'll show you here in just a sec. So you can indicate and then bump the compound around until you null the indicator reading there. Okay, now you can fool yourself a little bit, because if the tip of that is not dead nuts on center, okay, then you're going to have a problem. All right. Now, one way you can get kind of close, you can see I'm off a little bit there. I hope you can see. I can see it. Anyway, I'm gonna go ahead and just kind of stick that indicator ball right in that hole to kind of help get it on center. But you can see that this is a little bit of a problem to get on center, right? Okay, now we can bring it out. So that's kind of close. I wouldn't call that real close, okay? So, and then I'm just going to go ahead and advance the compound now. You just track along it like that. Oh, wow. Hey, look at that. That's pretty funny. Yeah, it's touching. Well, not bad for eyeballing, right? Okay, but let's get back to the problem here. So this is a round surface. It's a cone, right? So if you're not exactly on the center line, right? Let's say you're high a little bit. When you track on that cone, right? It's not a line anymore. It's you're doing this weird shape. Okay, it's a curve. It's this weird curve that goes along the radius. Okay, so it can give you a false reading. All right. So the right way to do it is if we had the ability to, and I showed this before in the other video, is what we did was we came across the top here, okay, and then moved up, and then we came across the top here, and we find the high spot. So ideally what we would be doing here with the indicator is we would be able to move it up and down, okay, to find that quadrant of that cone, right? Okay, find the maximum reading at both positions, right? So you'd traverse along, and or you'd start here, you'd zero, you move it up and down until you find the high point. You zero your indicator, then you move, and hopefully the indicator's not moving. And then as a double check, you do the vertical again, right? Okay, and null the reading, and then back up and do the same thing. Now, that's kind of hard to do with standard stuff here, and in particular with a setup like this, all right? Excuse me. And so there's another way, obviously, right, that you can do that so that you can actually traverse that indicator up and down. But it's not very convenient. If you have a height gauge like this, right, you can put this on the compound and clamp it down or something, or weight it or whatever. And this thing's nice and square, right? So you can move, you can move up and down perpendicular to the machine, right? and find that high spot at either end. All right. Now I'm not going to set that up because it's kind of a pain in the neck to set up, and not everybody has a little height gauge like this. You know, yeah, you can use a big one. Just know that it needs to be mounted on the compound. Okay, it can't be on the crossways or on the cross slide. All right, because it has to move. It has to move along at this angle, right? And so it's replacing this mount here that I'm showing here. Okay. Now I have a little thing that I can clamp in the tool post here, and I'm going to drag that out and show you how that might work too. Okay. Okay. So this is the thing I wanted to show here, and what this is this is it's a little dovetail slide with a rack and pinion that's off of a microscope. So it's just basically a linear motion, and it's attached to this bracket here. Now, I've just to dispel any comments that say that won't work, I've indicated this bracket, I've held it, and I've indicated it, so I know that it's very square. Okay, I've checked it. So over the full stroke, it's about 0.02 of an inch, full range. You know, whatever that movement is. Okay. Now keep in mind that we're going to center up carefully. So we're really only going to be moving this in a very, very short range. Okay. That's all we need to do, just to find that high spot. So let's put that up in there. I'll just clamp this in the tool post. Okay. And I had drilled and tapped a little hole to mount this very small Noga arm on there. So let me grab my indicator. All right, let's see what's going to make the most sense here. All right, oops. Now let's see, that's not a good angle. Oh, you know what? Hey, maybe, I very rarely use that little dovetail in the front, but this might be the ticket for this one here. Let's try that. Oh yeah. Yeah, look at that. All right, let's back this up a little bit. All right, so get kind of close here. And I'm just gonna kind of check it in that center hole there. Get things kind of squared up with the world. Take this off a little. And, you know, this is just to get it kind of close to start. Oop, careful there, Mr. Wizard. Okay, so now we come up. And then what we're doing, you know, I'm going to bring the camera around so you guys can see what's actually happening here with this indicator. The indicator is shaded here, so we should be able to get a good shot of that. And but it'll give you the idea of what we're looking for here when I say a null reading. Okay. So let me switch the camera. Well, there's an interesting angle. All right, so we're going to come up, and you know we're kind of close to center. So I'm coming up, and I'm going to touch off the indicator, and you'll see the indicator come up. Okay, right there. All right. Okay, so the indicator needle is 12 o'clock position. Let's see, can you guys see that? You know what? Let me back it off a little bit. Let's go to there. Let's go to the 0, and then you guys can kind of see it. All right, now I'm going to move this microscope slide vertically here. Okay, I actually got it pretty close. So I'm going down, down, down. Okay, and see the needle started to change direction, right? So let's do that again. Boom. Okay, so it started changing direction. Down, 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 right there. Okay. So that's kind of a null reading right there, all right? And then let's go ahead and we'll traverse along that thing with the compound. God, I can't believe it, I hit that angle. Oop. You know what, I gotta, gotta adjust my indicator a little bit because the, can you still see? Okay, good. The frame of the indicator was going to run into the part there. Okay, let's fish that again. Vertical, right there. Okay. All right. So now let's traverse the compound. God, that's like. I'm just astonished. I totally lucked out and got that angle pretty close there. Okay, so now I'm gonna do this again. I'm gonna do this vertical thing here, just to make sure that that we were tracking along the center, and it looks pretty good. So some of the, I can pull on this bracket. If I'm not careful, I can push on it. The bracket's not super sturdy, and the slide is actually kind of a stiff slide. Okay, but all we're doing with that is finding center. Okay, so anyway, that's how you can traverse vertically to make sure that you're really tracking on that center line. Okay. Okay, so the next method is called the, I don't know, I call it the bump, measure, and curse method of setting the compound. So now I kind of showed this in the last one here. What this is a gauge. This is just a shop-made gauge. These were just bored so that they're nice and round and then measured carefully so the diameter is known. Okay, so we know these diameters very closely. Okay, so it's a ring, and we can slide that on. So we have a large diameter and we have a small diameter, right? So what that does is that intersects this taper in two different places. So by measuring the distance between those rings that intersect the taper, we can derive the taper angle from that. Okay, and I showed this all in the first video, so I'm not going to go into depth on that on this one. Now, a viewer pointed out that I measured this with pins before, and he said, "Hey, listen, you can only discriminate, maybe within a half a thousandths with pins." On a bore like that, and he's right actually. Okay, so it really only tells you plus or minus a half a thousandth approximately. So by two adjacent pins. Now, if you have a plus pin and a minus pin, and you do a no-go, you can get a little closer than that. Okay, but he's right. It does change that measurement. Okay, so now I went back and I measured these very carefully with a inside micrometer that reads to tenths. Okay, and so yeah, these diameters changed a little bit. It only changed the number that I was using in my calculation by 2/10. Okay, so one of these, I don't remember what they measured again. I have to go look at my notes. But anyway, the idea here is this slides on. You measure its position. We know the length of this. You measure the position of that ring relative to this end. Then you put the small end on here like so. Okay, and you measure its position relative to the end, and then you can derive an angle from that. Okay, well, we can do the same thing when we're cutting here, right? So we can cut and take a measurement with this. Okay. And then adjust our angle and yada yada yada. So that's why I call it the bump, measure, and curse method, because it takes a while. Okay, but you can do pretty good with it. Okay, there's a better way that I'm going to show you in a minute here. There's a better way to do it, but let's talk about how this method works or how you can track your changes so that you know how much you're moving, okay? So this has a prescribed distance here, this length of this taper, and in this case it's about 25 millimeters, or it's around an inch, or it is an inch, and that's this prescribed length of a Jacobs 33 taper, okay? And so let's see, what else do I want to say there? So let's look at how we can track small changes in the angle of the compound when we're changing the angle of the compound. How a person might measure those changes so that they can do something in kind of a controlled fashion, so they know how much they're moving each time, and they can keep track of it, and as they do their measurements, they can work their way in intelligently. Okay, so let's take a look at that. Okay, so here's how we would track changes here. So what I'm going to move the compound out kind of to the spot that's the extreme travel that I'm using. So basically this end of the taper. So if you're starting here, you're moving an inch, so, and then you're going to move back and take another cut and take another cut, right? Okay, so we're going to basically move it out to that position, that far position. So let's get in a little closer here. Now, hopefully I didn't jump out of focus there or anything like that. You can still see that. Okay, so we're just going to traverse along here. So that's the what I call the short end, or the close end, and the far end. Okay, so we're going to be at the far end. All right, and you can probably do it at the short end, but I think you just have a little bit better resolution when you're out at the far end. As long as you do it in the same place each time, okay, near or far, I don't think it matters too much as long as you do it in the same place, okay? So what we're going to do is use this indicator here on our handy dandy Noga mount, okay? And we're just going to load it up against the end of that tool somehow. Now I know you can't read the dial just yet, so just take a chill pill. Alright, so I got a little bit. Alright, so I'm loaded up against the indicator, and let me wipe this off a little bit. Clean that a little. Let's take a look at the camera. Yeah, it's all blotted out white. So, like a few people selected or mentioned, this is a piece of this neutral density filter material here. And I was playing around with it, and it actually kind of works, but I got something better coming, I think. I'm going to rotate this around a little bit. That looks like a pretty good spot. So that kind of works, right? I mean, you can see the needle there. So now what we would do, okay, so we're loaded up on the indicator, all right, I'm on a line. I don't really care what line it is. All this is to track the change, okay? So let's say we need to bump this a little bit. So what we're actually doing is we're actually measuring the tool tip so that we know how much we're moving it, okay? So let's say the angle isn't quite right, and oops, you know what? Hold on a second, guys. Okay, so yeah, sorry, phone rang there. So now what we would be doing here is tapping on the compound a little bit, okay, and adjusting that angle, but watching how much we've moved it, okay? So what we would do is, we'd measure the angle and say, hey, we're off by 30 minutes of arc, right? So then we say we move, you can make a rough guess as to how much you need to move, right? Because you can derive what 30 minutes of angle is on that diameter and that at that angle, right? What that difference is at the far end, right? So now, because you don't really know your distance from the pivot point, it's kind of a moot point. All the important thing to know is that you track your movements, okay? And you make a little list on a piece of paper, and so you make a cut, measure, bump it, make another cut, and etc., etc. And it takes several cycles of that to get your angle real close, right? but you can do a really good job that way, and it doesn't really rely on things being on center line and whatnot, and you don't need a sample. That's the other thing, is you don't need a perfect sample. So you can derive your own perfect sample just from measuring, okay? So now the compound's pretty close right now, so I'm not gonna bump it and move it, because I'm gonna show you the last method, which is really I think the best method and the fastest and easiest, okay? Okay, so we talked about the first two methods of setting the compound angle real accurately. Just to review, the first is to indicate along a known sample, which this is. If you don't have a known sample, then you can use the Okay, so we've talked about, just to kind of finish this off here, we talked about the first two methods of setting the compound real accurately. One is with a known sample with the right angle, and we can indicate along that to set the compound accurately, okay, to match that angle, okay? And then the second, let's see, I'll put that back in, is with the two-ring method that I've described in the first video in this series. So if you want a full in-depth discussion of the two-ring method, then go back to the first video and we'll talk about it there. And this is where we check it with a known diameter, and we check it with a known diameter, and we calculate the angle based on where these fit, okay? And then the third, now this is the bump and cry method too, so the third and easiest method is to use a sine bar. Now, not all of you are going to have a sine bar, so some of these other methods are probably more viable for you. But the sine bar is really, you know, kind of the simplest and most foolproof method that you can actually, you know what, let's just take the tool post off completely here, get it out of the way. And it's kind of the most foolproof method. It's very accurate, and you can set any angle and you can set it pretty quickly. Okay, that's really the key, is quickly. Now, what we need to do basically is we need to set this at the proper angle and reference the compound here. Okay, so I'm just going to swing this out at some arbitrary angle here. And then what we do is we indicate along the sine bar until we know the indicator reading. Okay, so if this is set at the proper angle, then when this compound is at the correct angle, this will be parallel with the machine axis. Okay, now, you know, there's potential error between, you know, this surface and the movement of the compound, but there's not a lot we can do about it. What we can do though is, when we make a cut, we can check it with another method, okay, such as this, and kind of verify that we're cutting it properly, okay. Usually, you know, lathes are made pretty good, so this surface is going to be pretty parallel with the axis of the compound, I guess is what I'm trying to say. So let's set that up. Let's get this out of here. Kind of set these aside for a bit. Okay. So first we need to set this angle. So we need to take the sine of that angle, 84 degrees. Okay. And then we're going to multiply that result by 5. Okay, which is the center distance from here to here. Okay, that's 5 inches. And then what that is going to give us is it's going to give us a number. Okay, and I think I have it here. I already did it. All right, so it's 0.1587, okay, inches. Now, those of you guys that are following along, go ahead and do that calculation just to try it. Take 1.8184 degrees, get the sine of that, and then multiply that by 5, and that should be the number that you get. Okay? Okay, so normally what we would do with the sine bar is we'd stack up a set of gauge blocks under here. But, you know, that's kind of a small number, so it might be hard to get that number. So with normal gauge blocks, once you're down below 200 thousandths, it's they have a special set of thin gauge blocks. Well, what I like to do in a lot of cases is I use pins. Okay, all right, and we have, and you can see I marked the right one there, and so we have, this is going to be a 159 pin, okay, which is pretty close to 1587, but this is also a minus pin. This is a minus tolerance pin. So if we get our fancy micrometer here, wipe it off, and we take a measurement of it, so it's going to be a few tenths under 159. Okay, that's what. So it's actually pretty close. 15888. Okay, that's pretty stinking close. All right. All right. So we're just going to go with that. So now, what's next, right? So I think I may move the camera a little bit and get a kind of an overhead shot of how we set this up. Okay. So let me change that, and then we'll come right back. All right. So we're kind of ready here. So I'm going to put a parallel under this just to kind of help support the mess here. Okay. And we're going to put that up like so. And I'll drop this pin in here like that. Okay. Making sure the rolls are bearing on the against the compound. Okay. So now it's not clamped, but it's loose, which is not that cool. So what I'm going to do, I'm going to use a Johnny Woodworker clamp here, and I kind of like these actually because you can operate them one-handed. So what we don't want is we don't want anything to tip. So I'm looking under this rear roll here to make sure that it's sitting flat against the compound. And the other thing, I want to feel this and make sure there's a little bit of tension on that, which there is. Okay, so that's it. That's as much as I need to clamp that. All right. Now I'm going to get a indicator going here. All right. I'm going to back up just a little bit. Let's get this on here. This thing will go on here, like so. Okay. And let's rotate that like that. Oh yeah, this will work good here. All right, so I'm going to get kind of in the neighborhood here. And see, and I can move up. So, can you see the indicator? Not very well. Okay, so let me, I'm going to change the angle of the shot a little bit, but here's the general idea is we're going to come up, oops. We're going to come up against the sine bar there, okay? I'm going to touch off, okay, and then we're just going to traverse like this, okay? And what we want is we want a nice long stroke here, okay? And that gives us resolution when we come to here. So if we set this angle over a long distance and then we turn over a short distance, it's called leverage. We get better measurement resolution or leverage against the part that we're turning. So we're going to move, actually put that in gear so this thing doesn't jump around on me here. Okay, so just approximately we're going to be moving, looks like we can get about 3 inches out of it, and we're only going to be turning 1 inch. Okay, so we get 75 millimeters versus 25 millimeters here. Okay, so it's 3-to-1 resolution. Okay, so let me change the camera around, and then we'll, smart guy would have loosened those compound screws underneath there before he started, eh? Okay, well, live and learn. Okay, so we're set up here. Here's my starting position. Oops. Get your hand off of the chuck there, Mr. Wizard. All right, let's back up here. So there's enough wiggle in the chuck there. All right, we'll just come back and reset there. Yeah, okay. All right, so clockwise, we're getting closer. All right, so let's go ahead. All right, so it's fallen off. So in about 3 inches there, we've fallen off about 5 thousandths. So now what I'm going to do is I'm just going to use my little bopper here and tap that over. And then I always like to just reset each time. Oops, I went too far. Okay. All right, let's go back to here. So actually I was, Oh, I see, that's behind the pivot point. Okay, here we go. So at this end here, we're actually very close to the pivot point. So as we rotate this, we don't, actually, you know what, maybe what we ought to do is 0 here. And then, yeah, this is going to be better. We'll 0 here, and then we'll move to the far end, okay? All right, so that's getting closer, so we got to go back. Actually, I think I want just a little more tension on that. Okay, and then we'll reset. Let's get the most we can get out of that. All right, teeny tiny bit. Oop, going the wrong way. Reset again. You know, some indicating jobs, it's important that you make the adjustment on the same end. Okay, that looks pretty good there. All right, so now here's the kicker, is getting this thing tight and not moving it, right? As always. So I'm going to snug this one that I have good access to, and then snug the one that I have second good access to. All right. Get in there and get a little bit on that, okay. All right, let's sweep it again. Okay, looks like it's hanging in there. So I'm gonna move this a little bit. Once again, a smart guy would have positioned that maybe a little bit better. All right, let's try that. Oh, we can get a longer stroke out of it now. Oh, okay, that's a capital P there. All right, snug. Okay, so these two are pretty good. Now I want to move that sine bar out of the way and snug those down, and we're probably good to go. All right, so actually, you know what? I think I'm just going to take the sine bar out. Get that out of the way. Drop this stuff down. Get a little tension on these dudes. Okay. And then I'm going to put the sine bar up one more time just to verify that we're at that angle with all these kind of equally snugged up. Let's get that back. All right. Okay, make sure my roll's bearing properly. Okay, a little tension there. Okay, let's give it a go. So if we're lucky, this is pretty good. This is a lot faster than the ring method. Okay, so we're good. All right, so we got a good angle set now. So let's cut a test piece, guys. What do you say?